Before we dive into the announcement, it's important to understand what particle accelerators are. The Large Hadron Collider, LHC, operated by CERN, is a 17-mile ring of superconducting magnets and the world's largest and most powerful particle accelerator. It represents the pinnacle of human scientific achievement. In fact, it's so powerful that it can recreate the very conditions of the universe's birth. But could this machine designed to unlock the secrets of the universe hold the key to something far more ominous? CERN, founded in 1954, is one of the world's most prestigious research organizations. With 23 member states and thousands of scientists, it's a hub for collaboration and innovation. The LHC is CERN's flagship project, but it's just one part of a vast network of accelerators and experiments. Imagine a racetrack not for cars or horses, but for subatomic particles in a race against time and space itself. The LHC accelerates protons to nearly the speed of light, sending them on a collision course that mimics the energy of the universe at the time of the Big Bang. The collisions create temperatures 1,000,000 times hotter than the core of the Sun. Thousands of magnets guide the protons on their journey, while intricate cooling systems keep the magnets at temperatures colder than outer space. The beams inside the LHC collide at 4 locations around the accelerator ring, corresponding to the positions of 4 particle detectors: Atlas, CMS, ALICE, and LHCB. Each serves a unique purpose, exploring different aspects of particle physics. Together they act as colossal cameras capturing snapshots of these collisions. Scientists then sift through the debris looking for signs of the elusive Higgs boson, also known as the God particle, and other phenomena that offer clues to the universe's fundamental building blocks. By studying the microcosm, we gain insights into the macrocosm. But with every answer comes a new question, and with every discovery a new challenge. The LHC is not just a scientific instrument. It's a testament to human curiosity and innovation. It embodies our relentless pursuit of knowledge and our desire to understand the fundamental forces that shape our universe. Yet, as we push the boundaries of what we know, we must also consider the ethical and existential questions that arise. What are the risks of probing the unknown? Could our quest for understanding inadvertently unlock forces we cannot control? In the hallowed halls of CERN, where the boundaries of human understanding are constantly pushed, a revelation has emerged that sends a shiver down the spine of even the most seasoned scientists. Brian Cox, a former researcher at CERN and a voice of authority in the world of particle physics, has recently made an announcement that has left the world both fascinated and fearful. Cox's words resonate with haunting clarity. The goal of CERN's Large Hadron Collider is to recreate a mini Big Bang. Yes, you heard that right, a miniature version of the very event that gave birth to our universe. The physicist went on to explain the implications of this goal, highlighting the LHC's extraordinary potential for making new discoveries. This includes its ability to unlock the secrets of the Higgs boson and explore dark matter, a mysterious substance that makes up a significant portion of the universe. Imagine holding the power of creation in your hands, the ability to conjure the very essence of the universe. It's a tantalizing prospect, but one fraught with danger. The mini Big Bang is not just a theoretical concept. It's a tangible reality within the LHC. The temperatures, the pressures, the raw energy all mimic the conditions of the universe's infancy. It's like standing at the dawn of time, witnessing the birth of existence itself. But with such power comes responsibility, and the question looms: what if something goes wrong? In fact, something did go terribly wrong back in 1978. The Russian physicist Anatoly Bugorsky experienced a disaster that would forever alter the course of his life. While working on the U-70 synchrotron at the Institute for High Energy Physics in Protvino, Russia, a malfunction led to his head accidentally coming into the direct path of a proton beam. The beam, with a force that defies comprehension, passed through his skull, entering the back of his head and exiting through his nose. Bugorsky's experience was otherworldly. He saw a flash brighter than 1,000 suns but felt no pain. The beam's path left a trail of destruction burning through tissue and bone, yet he remained conscious and even walked to the clinic for treatment. The aftermath was both horrifying and fascinating. The beam's path caused localized tissue death, leading to the loss of hearing in one ear and partial facial paralysis. Yet astonishingly, Bugorsky's intellectual capabilities remained intact, and he continued his scientific career. This incident is not just a personal tragedy, but a cautionary tale that underscores the immense power and potential danger of particle accelerators. The risks of a particle accelerator like the LHC are not to be taken lightly. The potential for unforeseen reactions, the very fabric of space and time being manipulated, are not the stuff of science fiction but real concerns voiced by some in the scientific community. One of the most alarming and captivating concerns associated with the LHC's experiments is the possibility of creating a miniature black hole. Black holes are regions of spacetime where gravity is so strong that not even light can escape. They are cosmic vacuum cleaners, devourers of stars, enigmatic entities that lurk in the shadows of our universe. The idea that the LHC could create such an entity, even on a microscopic scale, is shocking to both the general public and experts alike. Could this black hole grow uncontrollably, swallowing the Earth from within? Though scientists at CERN have assured that any black hole created would be unstable and evaporate almost instantly, the mere possibility has ignited debates, fears, and a sense of awe at the power we wield. It's important to understand how the LHC could create a black hole. It has to do with the fundamental mechanics of particle accelerators. When protons are smashed together at nearly the speed of light, the energy released is so immense that it warps the fabric of spacetime itself. Imagine a trampoline stretched tight, and then a heavy weight is dropped onto it. The fabric bends and curves. If the weight is heavy enough, it could create a depression so deep that anything nearby would be drawn into it. That's a simplistic metaphor for what could happen in the LHC. In the world of quantum physics, where the rules of the universe are both bizarre and beautiful, there exists a theory that extra dimensions may be hidden within our reality. If these dimensions exist, the LHC's collisions could tap into them, creating a gravitational funnel that forms a microscopic black hole. This enigmatic dance of particles has even caught the attention of some world-famous scientists, particularly the late Stephen Hawking. In his book, he warned of a scenario where the Higgs boson could become unstable at very high energy levels. This instability could lead to a catastrophic vacuum decay, a cosmic event that would not only destroy the Earth but the entire universe itself. The esteemed British cosmologist and astrophysicist Sir Martin Rees also expressed concerns about the experiments conducted at CERN. In his book On the Future Prospects for Humanity, he explored the potential risks associated with particle accelerator experiments, including those at CERN. His words were not merely cautionary. They were tinged with a sense of existential dread. Rees spoke of a worst-case scenario where an ill-fated experiment could create a condition called vacuum instability. This instability could, in theory, trigger a phase transition that would ripple through the very fabric of spacetime, resulting in a cosmic catastrophe that could engulf the entire universe. Rees' concerns were not limited to theoretical musings. He assigned a probability to these catastrophic outcomes, albeit a low one. But even a minuscule chance, he argued, should give us pause. The scientists at CERN have calculated the probabilities, run the simulations, and examined the theories to argue for the safety of the LHC. In fact, Brian Cox himself has acknowledged the importance of responsible exploration. Recognizing the widespread fears and concerns surrounding the activities of the LHC, he emphasized the rigorous safety measures in place, extensive reviews and protocols that ensure the LHC's operations are conducted with the utmost care. Cox reassured the public that the energies involved in the LHC experiments are well within what the Earth naturally encounters. Cosmic rays, for instance, collide with Earth's atmosphere at energies far greater than those produced by the LHC, and yet no catastrophic events have occurred. Moreover, any black hole created in the LHC would be so tiny and unstable that it would evaporate almost instantly, a phenomenon predicted by Stephen Hawking and known as Hawking radiation. Such a black hole would be a fleeting moment of cosmic wonder, a glimpse into the abyss, and then gone. Some have gone further, speculating that the LHC's experiments could open a portal to another universe or dimension. While largely dismissed by the scientific community, this notion has captured the imagination of many and has become a subject of fascination, fear, and even folklore. What lies beyond our reality? Could we inadvertently unleash forces or entities that we do not understand? The idea of opening a portal to hell has been sensationalized in various media, adding fuel to the fire of uncertainty. The concept of parallel dimensions is not new in physics. String theory, a leading candidate for a unified theory of everything, posits that there may be more than the familiar 3 dimensions of space and one of time. These extra dimensions could be compactified or hidden from our perception, but they could theoretically be accessed or revealed under extreme conditions. Now imagine the LHC as a cosmic key unlocking doors that have been sealed since the dawn of time. When protons collide at energies never before achieved on Earth, they could in theory create ripples or tears in the fabric of spacetime, creating temporary portals or access points to these hidden realms. While much of this remains in the realm of science fiction, it's hard to ignore the weight of possibility. At the heart of this debate lies the question of responsibility. Should we be tampering with forces that could potentially alter the fabric of reality itself? With the LHC's ability to probe the deepest corners of existence, should we be worried about what we might discover? As Brian Cox and other scientists continue to explore the mysteries of the universe, one thing is certain. The pursuit of knowledge comes with risks, and the quest to uncover the unknown is fraught with dangers both seen and unseen. The story of the LHC is more than just a tale of cutting-edge science. It is a narrative of humanity's unquenchable thirst for understanding. With every experiment, every discovery, the universe reveals itself to us in ever more complex and surprising ways. But the question remains. When we unlock the deepest secrets of the cosmos, are we prepared for the consequences? Or will we, like Anatoly Bugorsky, find ourselves standing at the edge of the unknown, peering into a universe that we may not fully understand or control? The answer to that question lies in the future, one that is filled with both promise and peril. And as we stand on the precipice of discovery, we must ask ourselves, are we truly ready to face what we might unleash? As we consider the future of the LHC and the potential risks and rewards of its groundbreaking experiments, it's important to recognize the broader context of our scientific curiosity. The Large Hadron Collider is not merely a device designed for answering theoretical questions about particle physics. It represents the essence of human exploration. From the earliest days of civilization, we have sought to understand the world around us. In ancient Greece, philosophers like Aristotle tried to decode the mysteries of the universe through logic and observation. Thousands of years later, the Renaissance gave birth to modern science, with figures such as Galileo and Newton changing the way we understood the world. Today, the LHC is the latest and most powerful tool in our ongoing quest to uncover the universe's secrets.